Should be live, and welcome back. So I left off 2 days ago with the realization that I cannot trap the SPRR registers cleanly, except by trapping everything, which I don't want to do. And that tells me that probably the sanest way of getting macOS to run properly with guarded execution in my hypervisor is to just enable it and actually use the hardware feature, as opposed to trying to fake it and emulate it. But to do that, I need to actually enable it in Mini itself, because a guest cannot run with those features enabled unless the hypervisor has them enabled. And there is a requirement that there is no writable and executable memory in the hypervisor for that to work. And so that means that Mini cannot have any memory mapped as write and execute. Now, it doesn't bother me for like ad hoc Python stuff, because I can just have one writable mapping and one executable mapping for the same memory, and that's fine. And I can just implement that really easily. But Mini itself needs to have separate segments for text, read-only data, and so data here needs to be aligned, and I already align it to the page size, so that's fine. But that does mean that I need to actually support mapping subpages in memory.c. And what I'm thinking is that I'm going to just wholesale copy and paste this hypervisor page management code into memory.c. So PTRWX doesn't work, and RO. So we're going to need a PTRX, which is going to be the APRO. And UXN is fine. But I need to look at Sven's. I need to look at Sven's documentation to see how these things mapped, because these bits mean different things in SPRR mode. Where's the table? There was a table. Yeah, so it's indices, basically. And we're probably just going to use the same default settings that Apple used. Yeah, this thing. It does have a nothing, yeah. So let me see if I can make sense of this. Well, we can just make our own settings anyway. So before we go to that, let's just implement the proper mapping. So the issue here is, what I'm going to do is add a mapping as RW, and then override that mapping to map everything from base to RO data end. But I just realized this might be a little bit weird. I see how the build. I don't know if it's aligning properly. Start data start is, so that is aligned. Oh yeah, because I do align at the end of the previous one. Yeah, so that's fine then. So until RO data end minus base, and I need to declare these things here. I think we have some of those in utils.h, but not everything. Yeah, we have base and let's just put RO data in here. So this would work if this supported 16K pages, which it doesn't. So this is the writable by EL0 but not executable by EL1, yes. Except this cannot be RWX by EL0, but because SPR also forbids that. So we have RO EL0. RW EL0. And I guess we need RX EL0 because RW EL0 isn't, RWX isn't going to work. So, though actually, can we have EL0 RX that is RW and EL1? I think so, yeah. Yeah, because it's for different exception levels. You can't have RWX in the same level, but you can have RWX in separate levels. So and the thing here is I'm trying to make this work both with and without SPR enabled. And in fact, SPRs won't be enabled by default. So like the idea is that hopefully enabling it won't change anything too much. So EL0, RO, UXN, UXN. So you know what? We can afford to. So these need to be mapped differently. I never need to overwrite mini from mini. The only time that happens is when mini relocates itself, but that happens with the MMU disabled. So there's no reason for me to care about that. So I can actually, let's just make that RWX and then do an RW mapping for the mini executable section. Sorry, RX. Which is fine, because we're never going to write to that. In fact, that's probably a good idea, because it means if you accidentally try to write into, like, overwrite mini from mini, it will fault, and that's better than crashing. But that also means that I can leave everything that is running now the same way it is, not even care about the call stuff, except when I'm using the hypervisor. So it also means that unless I explicitly enable SPRR, any other experiments we do with mini don't have to care about any of this. And then I just need to make sure that these things are mapped properly. So it does mean I should do my own SPR config in that case. So let's see, RX EL0, RW EL0, RO EL0. Yeah, so we can do, because EL0 already has this funky mapping that is not executable by EL1, but is writable by EL0. Mini source. Let me undo what I just did there. Yes, so we can leave this in here as RWX at EL0. And what's going to happen... Actually, no. Writable EL0... Yeah, we can do that. So what we're going to do is leave that. And probably this should be Pt... PXN, because we definitely don't want to run from there. And now, the way the bits are mapped... Yeah, like that. So for Let's document this here. And the AP1 is the RO. So in that case, I'm going to you know what? We can use some macros and we can use some macros and convert this. So, and that way it's going to be a lot more readable. So basically perm and pt apro, that's ap1. And just repeat this. Equals 0. That'd be that bit, and then we do pxn, and then uxn. Put some parentheses around everything. Save format. And then what I can do is sprr config el1. And then the interesting values we need are going to be let's make an enum here and then just encode this table in there because it's kind of interesting. And it's not completely consistent, so yeah, this can be an enum. And then the exceptions here are Rx, R, RW, RX. Yes, so there's 0 Rx, R, and no RW. For the Rx, that makes sense. And then we have EL0. Zero. And then this is just X GLR. Then R GLR and RW GLR, and then this RW. I think those are the only two differences, yeah. And then we can define the a macro for permissions. The stream does work, by the way, right? Because I'm seeing no comments so far, but there's not that many people watching, so I assume it's working fine. So SPRR index. Well, let's do AP. Yeah, cool. Thanks. And SPR index AP and the I need the. Let me know if it's too small to read, by the way, because sometimes I forget to bump up the text size a little bit. What's the encoding in there? What was that thing? Apple regs. C61516. Yeah, SPRPL Mmio1, which should be should have the EL1, 2 thing through. Yeah. I think it's just from the little bit. Yeah. It's SRF, yeah. Index 1, yeah. E F2, F6, yeah. Yeah, it's just it's pretty much the obvious thing. So config EL1. So here in SPR index AP, 4 bits for that. It would be val to the left that. And then basically what I need to do is for EL1 we have perm basically let's just do read W for everything. For all the EL0 related stuff, we can just do RWs. RW0, RW0, RX-EL0, RWX-EL0. And then for the for hours, for RO, let's do this properly. And RDLR, RW-EL0, RW would be RW, RX would be RX, RX, and RWX is the one that is going to become RW. So for everyone who is asking about the hypervisor, I just sent a Patreon update. So let me link you in the chat. Hold on, give me a second. Find it here. So I got the chat on the other screen. And it's a public update, so you don't need to worry about being a patron or not. Can I pin this? Yeah, I can. So hopefully that works. And you can read about why I'm building a hypervisor there. Okay. And then an EL0. Basically, well, these are kind of the same thing, actually. Actually, I just realized, can SPRR break the architectural ARM BS that I had an issue with, where like EL0 can be allowed to write to EL1 executable pages? That's going to be interesting, actually. I should test that. Yeah, I wonder. We'll see. We'll see about that. That'll be an interesting experiment to do. But it's not going to be encoded in the default. So for your RO, let's see, RO. Does guarded even make any difference in EL0? Like, I just realized, like, the register has a bunch of bits for guarded execution, but does that have a meaning in EL0? I'm pretty curious now. What does that do? Yeah. That's very interesting. Well, let's do the same thing here, where we map GL and EL the same, and then I guess we can find out if we can run guarded exec in EL0. That'll be very interesting. Okay. So EL0, we get RX here, and RWX is also just going to be our W. Yeah. And we were using RWX for EL0. So basically for us, yeah, these are the same for our EL0, and then for RO, RW, yeah, we want these to be the same for EL0 for our purposes. And that will... Actually, no. How was I doing this? RWEL0 for everything, and then RWXEL0 and perm RWX. Oh, was I think my call thing already called was set up to L0 call. Was that already set up to do the mapping properly here? I think it was supposed to be mapped as... Hold on, did I just mess this up? RWX is 0. Huh? That doesn't make sense. Oh yeah, UXN is not set, so it should execute from that memory. And... hold on. Was that making it execute only? It might. Hold on. Where is the EE permission stuff? Here, yeah. And there was a nice table somewhere with this stuff. Where is the full table with everything? Here. How about WXN? There is a... yeah. So basically, Apple enforces this on when... effectively when SPR is enabled, but we're not doing that. So in this case, if all 0, EL0 is executable only, yeah. Is that the current state of things? I think it wasn't intended. Hold on. It's interesting what just happened there. Shell.py. I think that's... let's see. But then the stack wouldn't work. That doesn't make any sense. I mean, that does work, obviously. Nop. Whoa, that didn't work. I did a lot of nested exceptions. Maybe it doesn't work. Data abort lower. Uh-huh. Yeah, so it probably failed on like the fetch from that constant pool. Yeah. It definitely failed on the fetch from the constant pool, and then what? How did they got a data abort, and then what? Then how did we end up? I think this is a bug somewhere. This is not supposed to happen. Like it recovered, but why is it throwing 4 exceptions? I mean, NOP works, and I think these are mapped as nope. But that's probably an actual fault. Let me find an actual. Oh, and I can't load the. I can't load that address. Huh. Now something's broken here. Like exception unknown. Clearly something is weird here. uh huh? It does work eventually though. Okay, hold on. Listen, what's going on here? Um yeah, it's just a symbols and then oh, hold on. Oh no, I have a padding problem here, don't I? Right. This is gonna pad, and then I'm running like undefined instructions. That's what's going on. If it's a string, then let's just do it like this. Yeah, we got one exception, not a million. Yeah, and that's a data abort, but actually loading from something that is a real address should work. Like that. Or not. Huh. Wait, far is... Oh, yeah, it's the self-reference. Okay, yeah, so this is actually broken. Indeed. I broke this at some point, or we weren't using it. Yeah, so... Yeah, because I never ran anything that used like constant pools like that from EL0. So this is not right. This is what I want is like perm RDUX EL0 is actually what I want for all RAM. Just like oh wait, no, that doesn't. It has to be RWX EL0. Yeah, so then I need is like EL0. Oh wait, that doesn't work, does it? I can't have something that is read-writable in both EL0 and EL1 and executable in EL1. I need to have RO EL0. Yeah, so I want something that is... Oh, but that doesn't work either. Because RO is only... I really dislike the way Apple does like page permissions. RW executable. Executable ES0. Yeah, there's no... because RO is global. Yeah, okay, so there's no way to do this. So we effectively actually, for one, the EL0 stack is broken. I need the... this RWX EL0, yeah. So we need a bunch of different things here. So we need an RWX EL0, but then we also need an RW EL0 for when you use SPRRs. And we need an RWX, an RX of everything for when Mini wants to run things from a different address in EL2. Yeah. Yeah. And then effectively the stack needs to go into this region. Let's make some defines here for that. And we can do it like this. One more 0. Yeah. I have that right? Yes. Rx. Rx EL1 on A. Okay, so that should take care of that, and then maybe fix the... yeah, why is that we don't need PXN for that. That's not needed. These aren't technically identity anymore, so. And this would be A9. Yeah, and then in the EL0 run. Oh, is that just it's only in the ASM, isn't it? Yeah. So EL0 call needs a stack base. That is actually set here. Does this work? Actually, I can probably do it like... I don't think I can put ors here, but I think I can do and, which is good enough. Memory.h, region RW 0. Let's do it like that. I don't think this will build memory. Yeah, but that should work, yes. Plus works. Oh, but no, that's fine, because the original address is physical. And then I need to also pass that in the call. Dive clear, thunk stack base. Yeah, so this is the execution is fine from here, but the target address should be relative to this region, because otherwise constant pools aren't going to work. Or are they? No, they aren't. Hold on. Memory.c. Yeah, they aren't. It's execute only, so... Yeah, it should be running from the RWX user, which becomes RX when with SPR. And X5, X0 is that, yeah. think mob works here. And can I... where's the assembly thing here? We had some kind of types, was it? Yeah. Can put this in here. And in that case, I can just include memory.h. Let's try building that. Cool. Huh? 0. No, wait, hold on. XCL1. All right, that builds, and now the issue is this one isn't going to work. But let me do a quick check. I'll comment this out, build, just to make sure that the EL0 things I did work. Aha! Okay, I fixed the EL0. That's good. And now this is the other missing bit, which is that this code does not support mapping subpages right now. Not subpages, sorry. Constant pools are PC relative, but R0 there was the destination address, so it's the address we're jumping to. So I want to jump to the loaded code at the mirror where data accesses are allowed for EL0. And so I'm going to steal a bunch of this code from the hypervisor thing. Now we have the attributes. Wait, we have, L2 next, and basically HVVM. I'm tempted to just replace all of this wholesale with what I did in the hypervisor. Why is there a semicolon there? this used for anything? Yeah, to get the L2 table. Yeah, so I think I can just copy and paste this code and simplify it a lot and kind of replace this whole memory management thing that Sven wrote. Sorry. Because I need to split page tables and things, which is already implemented here anyway. Let's move this down here. Ooh. And basically clean this up. We don't need that. We can use lower attributes. Valid, type, block page. We have those. And then we don't have an L4, so that's fine. There's no L4 table. There's no SPTE. You just say SPTE. It's no software. Is block. SPTE. Oh, this is going to be the same thing. It's not table, it's going to be as block because it's always the same. And L3 is always going to be page because there's no table there. So we can get rid of that. And then basically free L3. There's no free L3. So map L2, map L3. And let's just copy and paste this and clean it up. And then here, instead of HVL2, this needs to be like the same as the get L3. So PT map L2 from to size. We don't need increment because it's always going to be set. Just replace that with nothing because it's always going to be that. There's no software. And then in get L3, we need a get L2 also. L1 index, L1 offset bits. Page table. Let's just call it like this. Maybe TL1. And page table 2 is going to be dynamic. And I can simplify this by just saying that the L1 table is just twice as long, contiguous. Actually, didn't ARM already have something like this? I think there was a thing for setting the pages as contiguous. Concatenated, yeah. Oh, that's stage 2, though. But not for stage 1. Okay. Yeah, so let's just pretend this is a larger page table. And then we have to add the L1 things here. L1 offset bits. Oh, did I miss stuff there? Yeah, I've got text missing there, don't I? Oh no, I do have it. L3 index bits, L1 index bits. Uh, 36. And there's not going to be any L3 on the mask because there's no 4 bits. Entry spare L1 table, bit, L1 index bits, yeah. Then we do L1 is stable, L1 is blocked, that's the same as L2. Get L2, find the index in L1 index. And that would be L1D. L1 is stable. L1D, return L2 and PT target mask. Mm-hmm. So if L1D is a PTE, then no, in this case, it's going to be the same. This is going to be switching to page, because in this case, L2 is also going to be block. And the increment is always going to be right, so that's fine. So we don't need that code. Entries per L2 table. L2D increment L2 is L2D, which is the same as L1D in this case, because they're going to be blocks too. So otherwise, entries per L2 table, it all gets it to 0. And we can just set this to like is PT. And the increment is 0. And this is just going to be increment equals L2 offset bits. Yeah, get L2, it just looks like this. So we need a map L1. And this is the one that's going to be the same. Mmupt L1. If it's a table, we just free it. And the index is the 2. No increment on that. L1 offset bits, L1 offset bits. Yeah. We have get L2. PT map L2, and then we have L3. Yeah, so PT map L2 needs to work like PT map L3 actually. And there's always going to be hardware, so PT page. New PT. L2, L2, no, it's software. and then L2 offset bits. The index, and then do get L2. If L2 is stable, L2 index, then free, and then set it to 2. Increment, no increment anymore. Not for these. And then remove Pt map L3. That makes sense. And then get L3 is going to be the same as get L2 actually. Minus the, yeah. So from the offset bits. It's more like get L4 is what I need. Yeah, 3 would be like this. 2, get L2, L2 index, L2D is L2, L2 index, L2 offset, L2 index. L2 is stable, L2D, return, yeah, 3, target mask, otherwise allocate. Entry spiral for table, if L2D, the increment is always enabled on this. And this is basically the same as before, so we just need like an SPT thing. So in this case, because it's L3, set it to page. The increment is always going to be offset bits. So do it like that. And then set the descriptor. Otherwise, mem set it. And the L2D is going to be L3, field type table, BT valid, the L2 index, L2 is L2D, return L3, cool. And then map L3, again, notice software. 2 should always be a page, hopefully, so. L3 offset bits, gets the L3 page. It's not going to be a table in this case, ever. So that's like map L4 in this case. Yeah, it's exactly the same as that. And then L3 offset bits. And then obviously this goes away. And then finally, MMU map. It's always going to be hardware. No increment. From a mask or size on mask. If from and this it's just gonna be L3 because it's no L4. There's no L4 mappings to boundaries, so this is gonna be L2 offset bits from if chunk, no assert, map L3. This is the same code, isn't it? Yeah, it's the same code. It says below. Min size, align up. Align down. We need the, yeah. Min size, align up from minus from, yeah, L2 offset bits. What was this doing with the line down, align map, down mask L3 offset bits? Don't quite remember what this was doing. This feels a bit weird. I line up the from address. Subtract, yeah, that's to get to the boundary. But only, it only makes sense if the 2 is also aligned, isn't it? Oh yeah, because L4 mappings don't matter for us, but they do for... I think some of this code is a little bit broken here. It would be L3 mappings to the if chunk, and if it's hardware, L3 has to be aligned. So that doesn't need that. Okay, so it doesn't need it, but line down min size, yeah. Go to the next offset at L2, and then it does a line down on L3 offset bits. Yeah, so that might go to 0 if we got to the boundary. Oh, if it's like covering like a subpage, it'll do the boundary, and then yeah, okay. So that just goes it down to 0, and then yeah, that makes sense. So in that case, yeah, that's to make sure that the final L4 mappings happen properly. So that only needs to happen in the intermediate. Okay, that's fine then. So L2 mappings to boundary, yeah. If I line down means size line up, L2 offset bits, that would be L1 offset bits. Yeah. Chunk, L2 from to chunk, no increments. Size, and then we do L1 mappings. So this check needs to happen here too. Here we didn't need it because L3 is always going to TTP9 to the hardware, and the software can deal with unaligned mappings, but hardware can't. So this needs to go in like this. Oh, not hardware or, yeah. Too many. Like that. Oh, that's fine. I think. From to chunk, boundary, L1 mappings, map L1, L1 align mask. Yeah, L2 offset bits, L1 offset bits. Yeah. And then we go back. L2 mappings to end, L2 offset bits, L2, no increment. And then finally L3 mappings to end, which is like L4 here. Okay, I think this might work. Put this documentation up here. Oh, block maps for L1 are not possible with I didn't know that. Block maps for L0 L1 are not possible with syncing KPIs. Really? So then I can throw away that code. Where is that? I find it really hard to figure out what I'm looking for in this table of contents. It's always the same with this manual. Encoding, here we go. Descriptor. It claims it should work. Oh, wait. Oh, this stuff. TCRDS? Yeah, it's like the expansion thing, right? So if that's 0, then it's not supported, was it? Yeah, interesting. Okay, so in that case, this can basically go away. map L1 is never used. Which simplifies things, actually. Yeah, that's pretty simple, isn't it? Simpler than the hypervisor one, even. And this is L3 mappings to end. And we don't need these anymore. Make it TLBT, mirror index. We're going to pass those there. So basically in... memory.c. We don't need to panic on this because we probably want to make these addable from the to these. Basically, from to no, we don't have any of those yet, but we probably eventually will. So I'm gonna change this to U64 just for from to size, and then attribute index is the part we need, and perms, and then that is done with with the attribute index. T access, is that used anywhere yet? The way I did it in the hypervisor is should be the same roughly as here. Yeah, attributes invalid. Attributes is set to access, and the sharing stuff and the attributes, yeah. And the perms are in terms of those, so that's fine. And then where's the like sharing stuff? Let's delete some stuff here. None of this is needed. None of this is needed. And then basically just set L1 0. And then page table 0 is equal to and just do it like that. Tap. Entries per L1 table is the one we cheat. L1 index, well, actually, we don't really do it like that, but just do it, divide by 2, I guess. And we don't need that because that's handled by the thing above. But I guess that's fine. We don't, it's not, yeah, it's basically index access and perms and valid. Okay, you do that. Are you using this anywhere? I don't think so. I'm using this in the walk. Yeah, we don't need that. Something like that. Okay. PT get L2. Let's see how badly I broke this. Yeah, we don't need these anymore. Actual two tables, internal table, page size. Yeah, that goes away. And it's actually entries per L1 table. Align, we need malloc. Okay, L2D, this is L1D, isn't it? Yeah. Oh wait, but L1D can never be a page table entry. This can never happen because we don't do block maps at this address, so... If it either is a table and it's already there, or it's empty. Assert, yeah, we need that. Okay, L3, this is L2. Okay, next crash. L2D would be get L2, L2. And this is actually L1D. Table valid, yeah. We don't need increment, where is that? Yeah. This parameter increment, yep, that goes away. Type block, yeah. Do it like that. Actually, we don't need this anymore either. Flag access, SSPT access. Okay, getting there. PTL1. You get L2 table. Yeah, single mapping that goes away. Just that mapping does it. Okay, and then we map from to, yep, BT access, valid, mirror index, and perms. Just like that. Page table L0, yeah, MSR. We don't really need this DTBR1 either. That's kind of just like for fun. Cool. Okay, now it builds. How badly is it going to explode? Probably very badly. Okay, first I'm going to test it without the mini executable code mapping thing. I'd be very surprised if this actually works on the first try. Okay, let's see. Get a serial port, chain load. That did not work, did it? Ooh, but address 0. That's interesting. Oh, wait, you got more than one problem here. Boot args during DL2 initializing S error. Oh, S error. Ooh, and that failed on address 8. Probably, or is that PC rel 19B00? What is that? That's wrongish. Is that malloc? Is that failing malloc? Yeah, interesting. Okay, let's try that again. Let's see what happened. Actually, you know what? Let's do that again. Yeah, it's reading from 0. Interesting. And 10B00, and that's why there though? Is it just a speculation or something? Load 116, yeah, it's just that, isn't it? No, why? X1? That's not, no, the X1 is fine. How is that happening? Is it because I mapped something wrong and then it translates that to somehow... But it's failing in malloc though, so... Like, it's before it even gets to this. And so it's fitting in init page tables before any page tables are initialized. So it's writing? Like, S-error usually means writing, right? And then it gets a sync on 8, which is the same thing. But now it's 19B and then 1A718. Okay, I think the S errors are kind of bullshit, but the sync is going to be more interesting. 1A754. I think that the PC doesn't... yeah, okay, that's more like it. X08. Yeah, that is a null pointer dereference, right? And then internal memo line. Interesting. So it's failing in memo line. Am I like overflowing a buffer or something? Probably overflowing something. You know, the fun thing is I can run this in the hypervisor and debug it that way. If I can't figure this out really quickly, I might just do that. But let's see what happened. It's a null pointer dereference, so it sounds like I'm like messing up something here. Entry per L2 table, L2, yeah, that sounds reasonable. And then memo line, L2, it's probably some index thing is wrong. L1 index. Sikro says that they didn't get a notification for the stream. Yeah, I think YouTube can be weird about things like that, and sometimes it like just doesn't send out notifications properly. I'm not entirely sure why. Okay, first of all, let's do that. That's going to be useful. Let's try building that again, see if I get a... No. Actually, 0. Okay. A bit of printf debugging. Yeah, it fails on the first one already. Menu map. Yeah, that's fine. L2, yeah, it goes to L2, PT map L2, and here it should do like get L2, which is going to look in PTL1, and then if it's a table, return it, but it's not a table, so then it's going to memo line and entries per L2 table. Hopefully it's not a PT, and then it sets that to 0, and then L1D is L2 or field prep, yeah. Index. If it's a table, I'll free it. What did I do wrong here? Probably something dumb. Ugh. Map L2 calls get L2, and then that crashes. Why? It's just memoline. How is memoline broken? I'm confused. It's just failing on the very first allocation, if anything. I mean, there's no malloc in it. That should all be static. Or is it heap? Oh, did I initialize heap? Oh, hold on. Ah, shit. Ha ha ha. Hold on. Why is that not? Yes. Yes. You know, I need to have a thing here so this actually has like a top of heap, so it doesn't just return garbage. But yeah, indeed. That would help, wouldn't it? That was really dumb. And then this should basically just work now, right? Yeah. Well, okay, it fails after enabling the MMU, but at least we mapped a bunch of stuff. And in fact, we kind of mapped A lot of things, actually. Yeah. So I don't need that. Probably messed up some of the mappings. Nothing changed here other than some assert, but what changes here in main, I have to initialize heap block before the MMU, because I'm using malloc in the MMU now, so that was the dumb thing. So I'll go to... Yeah, so now this is going to be a lot easier to debug from... Because before it was a weird crash, but now this is like a MMU failure. So this is a perfect time to do hypervisor debugging. Because I can just do run guest. Mini Mako, and see, yeah, do that. Run guest. Let's see what happens. Oh, not S, no symbols here. Haha. What happened here? Unknown vector. Yeah, those are the crash ones. Unknown, where on? Is it assuming EL2 somewhere? I think it's assuming that somewhere. It would be nice to load symbols from ELF files here too, wouldn't it? I already have a Mako symbol loader. That's so dumb. The interesting thing is it is going into the exception handler here. What is that? 361512? Huh? Oh, GXF. Why is it calling GXF init? We're not doing GXF anything. Are we? Oh, startup. No. Hey, Sven, you broke the... yeah, let's not do that. Okay. So it still crashes. Interesting. I would have expected a page fault. Oh, wait, but it can't even read its own memory, right? So it can't even run my hooks. Ooh, okay. So this is actually kind of useless. That is annoying. And there's no, like, CTLR. There's no, like, only translate data access and not instruction accesses, is there? Yeah. Okay, so I'm going to do a little cheat here. Let's crash it with an undefined instruction there. Ooh, not ARM. Awesome. Yep, and that does work because because it assumes SCTLR is in. So let's do we did do the print, so we can actually just set it and then do a translate, and it doesn't work. And the tricky thing is I want to know where it failed on that, which is available. I just don't have the. Basically, what I need to do is S1 E1 W with that. That did not work. Yeah, that's fine. And then res par EL1 801, and then we look at that. Tells us what the problem was. Faulted as expected. And then 801 means address size fault. Ooh. That's pretty bad. And then 8 is bit 11. Yeah. Reserved one. Okay. So it's like the earliest address size fault. Interesting. TTBR0. These are both set the same. Those are not. I don't think that's correct. That doesn't look right. That looks like it's missing the valid bit. Oh. Hold on. I think I'm missing the valid bit, but why? Table address access. Why? Oh, because those include the... Right. Okay, so that might help. Is that the only issue then? Set the 1 bit on that. Do the translate thing again. Haha! That worked. So maybe that was the only issue. So what if I just continue now? That still didn't work. Oh, sorry, because it went back to the unknown. No, it should be the next one. Okay, but it could be a TLB issue. So let's just reboot that again and try it again. Let's do a normal chain load first. That did not work, but at least we got a fault. At 10.36. Yeah, we at least got a fault, so it's not completely dead this time around. Let's see where we are. Oh, the undefined. Yes, duh, sorry. I did get rid of that. Let's try that again. Still okay, now it's dying again. So what is the issue now? Is it that we can't execute code, maybe? Might be a permission issue. I'm mapping this as perm OWX, which is 0. Yes, before. Kill that. Let's run it as a guest again and stick that undefined in there again so we can trigger. Must be that we can't run code, so let's see. I'm probably messing something up with the table descriptors. Let me do a quick look again at how that looks like. Where is that damn thing here? Find translation behavior, translation. What is the for encodings here? So page level 3, not level 3. It should be a not level 3. You need level 1 and 2. Here. And then if I translate, yeah, that does work. E1 robot reads. That's the same. Doesn't matter if it's E1 2. EL0 should also get it, yeah. And how do I know if it's executable? Probably by looking at the output from that. Par. So if it didn't fail. Wait, no, it did fail. Hold on. Oh, sorry. It did fail. And that's a different failure. No. Hold on. Successfully risk 0. Oh, sorry. So that's the input. I'm dumb. Forget. No, it's still broken. Hold on. I'm dumb. So is it a setting issue with the TTBR0? That doesn't really look right. That looks like an SCTLR issue, but address size fault. It's like, is it just an SCTLR thing? It should be the same setting, right? 30D, blah, blah, blah. And the one that I booted before with, which is fine. I'm Mmu 3090 1185. Ooh. No, that's different. Hold on. Oh, is it just because... Wait, this is just... What am I doing? This is wrong. What is this? Hold on. I'm dumb. Why am I even trying to translate something that doesn't make any sense? Hold on. I'm very dumb. No, it's fine. It's translating fine. Was it a CTLR then? Hold on. Just try this again. I got confused there for a second. I feel like some gunk is in SETLR EL1 and we're not resetting it. And why aren't we resetting it? Oh, we don't... We keep old settings. Why? This used to work in EL1 though, which is weird. Okay, let's try that. And then translate. Okay, that does work. What about some code? Yeah, it translates. That's weird, though. That's a bunch of gunk that I don't want to do. This got converted from that to that. So what if I... just do that for a second. Oh, so I forgot that. Turn that off. What happened now? Exception sync. Okay. Now what? Interesting. So now it's actually faulting. Yes. Why? B0F. Okay, that's more useful. Par... F is... translation fault level 3. Okay, that makes more sense. Probably messed up a block descriptor somewhere in level 2. Oh, this is wrong. It's block. That's why. Yeah, that's why. So I copied and pasted that from the other one, and that doesn't make any sense. Okay, so in that case, kill that again. Try it again. Aha! Now it works. Okay, so where is that nonsense SCTLR coming from? Is it, well, we just never initialized it, which is not a good idea to begin with. So hold on, let me just see if it's just there to begin with. Shell. Come on, boot. Come on. So yield 2 is that, same as yield 1, 2. Oh yeah, there's a bunch of crap there. What is that? We should just initialize it properly. What is that bit even? This stuff there doesn't make any sense. How did this work before, though? ICM span. So what is this? And we don't have defines for this. Let's make one. Well, we don't have it set right now, but like, what is this even? What are these SCTLR settings? I mean, what I want is this anyway. So what bits are here? I guess setting. You know, it might actually have broken because I updated my OS, which means I updated iBoot, and maybe iBoot is setting different settings now. Because the last time I tried running Mini under the hypervisor was before the upgrade, I'm pretty sure. So maybe that's what broke it. That would actually make sense. So let's see. 20, that's 24 and 25. EOE, EE. Let's just break everything down. What? Hold on, am I calculating bits wrong? No. 30, 29, yeah. You just do this in binary. Actually, the one I want is this one. Makes a lot more sense. And now we have 10 bits, 10 bits, 10 bits, 10 bits. Okay, so this is bits 8, 7, and 8, which are reserved 1, ITD. Yeah, so that's fine. And 8 is SCD. Yeah, let's call those res1, SCT, and RC. And those are actually defined here, I believe. Yeah, ITD and the CD. So basically we have TD, SCD, and I is before that. CM. Span is where? Span is before everything. CM. And then the other bits would be bit 20. Yeah. Oh. And yeah, we don't have this as reserved one. TCS CTX. That is between span and I, and then we have, where am I? bits 28 and 29, which are, yeah, those reserved one, right? So NLSC, whatever NLSC mean, yeah. So basically setting them all to 0 would be sane, because these are reserved anyway. These are non-implemented things that are basically set to CT and ITD. Okay, that will hopefully fix that. Let's try running it as a guest. Yeah, cool, that works. And now running it as a normal thing, hopefully that also works. Oh yeah, that's dumb. Thanks. Cool, yeah, that works. Now I can get rid of all the printfs here. Don't need that. Another chain load. Yep, that makes sense. And now, is this going to work? Yep, that worked. We can call this remap, meaning execute code as Rx. And this is a good time to commit everything before I get starting on SPR. Status. Should everything be in source? Not that. Yeah, should. Let's do that first. MREH. That one can be fixed later. That's just garbage, but actually. Let's do the heap block thing first. And then so yield 0, stack base. And then in memory, no. Let's just do the, let's do that, not that, then not that, but basically split that, not that. Yeah, so that can change, split that, need identity mapping for that. We're not doing that one yet. We're doing everything else. Not that one, and not that one. And then you need the beginning of that file. Just the part about the permissions rxcl0. Hold on. Split. Yes, I need that and that. And in principle, nothing else. Yeah, so that sets the stack, sets the region, adds those two things, the comments, and then maps those regions. Yeah. It's on work stack and then what else? There was a different thing here. I can add. Yes, do that. I think everything else can just be done in one go. Assert H, malloc H, pt valid, type block page access. Yeah, all this can go in. Okay, cool. So this all looks good, and actually that needs a space there. Okay, and hopefully, I actually don't know what this gxfinit is doing all this early, so let's find out. Sven added this, and xfinit does assembly probably. Okay, it just turns it on, sets the gxf config, and then turns it on and adds the gxf setup as the gxf enter EL1 and okay, yeah, it's just setup. Yeah. So that's fine. And how does the vectors get set? Mm-hmm. Oh, okay. It sets it to right, and then it calls genter. That sets everything up. And I guess this can be locked somehow afterwards, I assume. So, in memory, I can probably just enable SPR at this point. So let's try to do it manually and see that nothing breaks. So I just do shell, and I need to know what this value is, though, which is kind of annoying. In memory.c, I'm just going to print it. Actually, I can just set them, because setting them is not going to break anything. So basically, just do init SPRR, and then basically, most of this could be written in C, to be honest. You have an ISP in here? Yes, it's just sys up ISP. Oh, MSR sync is useful, yeah. Apple CPU ranks, PRR. Oh, we don't have those? CPU regs. SPRR permeal 0, yeah. Let's go default perm. Cool. Format that, and Let's chain load, and that shouldn't break anything because it's before the MMU is enabled and we disable it afterwards. So, is it build? No. Oh, interesting. ELR. Oh, sorry, R. ER. PXN, not AP. It's just PXN. Ooh, that's weird. SPR index. Oh, yeah, I'm gonna need that. I'm out. Hmm. Oh, hold on. That's not right. Oh, it is right. Interesting that it. Oh, it thinks it's a cast again. It's not a cast. Let's try doing it like this just so it doesn't look bad. But still, that's what am I missing here? Something dumb. Oh, ORS, the ORS here. Aha. It's less readable now though, but okay. That builds. Let's see if it runs. It does. Excellent. And now, with the SPR enabled, not enabled, it's disabled, but it's configured. So let's see if I can just enable it. Will it break? It does. Whoops. Right, if it's not enabled, I can't do that. Let's see. How can I test this? I just AT. It does translate. What about writes? Yeah. What about base? That does translate. Oh, because translation is disabled. Oh, interesting. Okay. So it does do that. AT. Can I kind of cheat this? I might be able to just kind of cheat this. Actually, I can EL1 call something, which will copy the settings to EL1. And that's in exception.c or something. Oh wait, no, that doesn't even copy them. I think we're just running translation disabled. But I can just do the same thing I do in memory for the init, which is pan is 0, and I need to set the configure my TCR. And now I can do and then if I do that again, S1 E0R, that should work. E1 W, that's fine. So that does work. Why? Hold on, that should fault. S1 to E1 W. That does enable it. Oh, that could be. Now I'm curious as to why this is working, though. 0 should not be mapped. Why is this working? Oh. This should be failing really badly. Why is it not failing? 0, 0. Does it only work if like If it's enabled in EL2, I thought that would work. Oh, yeah, no, that does happen. S-sync or something. Yeah, okay. It was an ISB again. And I need to turn off the frame buffer, obviously. P was it? Or U? Or what was that? Whereas IODevFP, I changed the way these defines work, and it's not the same thing now. Yeah, I need everything in the module level of this to be loaded. IODevFB, it's proxy. No, it's Oh. Huh? .fb. Yeah. Okay. TTBR. Why is that not remembering the... I think like when something weird is going on with like... TTLR on 2 TTBR. Oh, sorry, I broke that. Okay, now it's throwing an exception. Data abort. Oh, because stage 2 is not set up. That's fine. And yes, this is faulting, which is the interesting thing. 80D. But wait, SPRR is enabled in the host but not the guest now, so why is it faulting now? D is... six. Translation fault level 2. Oh, yeah, because this is actually a bad address. Yeah, okay, so that does work. And now can I enable this PRR? Config. Yeah, so if I do perm EL0, EL1, EL12, put that in the... Yeah, oh, it doesn't work. This is going to fault because it's going to be... No, that does work. Interesting. I guess as long as it's enabled in the EL1 is 1, EL12 is 0, yeah. Turn it on in EL12, and then can I translate? Still works. What if I do EL1 call, actually just inst nop? Thinks it's probably going to fail because the exception vectors aren't going to work, right? Even though translation works. R, yeah, RW works. Because I don't know if this address translation stuff works properly with SPRs. Actually, there is that Apple address translation instruction. Let me try using that. Instructions. And then that returns it in R0, which is convenient. Aha! Oh, that's... so I wonder what this is doing exactly. It's definitely different. It's definitely a different result. And I don't know if that's... EL1 or what it is. So if I set TT, I don't know why the search doesn't work. If I kill the guest translations and then try that, that still works. So is it translating for me? No. How do I flash all the TLBs? That's still there. VML1, then it's, I'll just do L1 and L2 and yeah, no, it still works. I don't know if that's just because translation is disabled. It could be. It's enabled in there, but yeah. So maybe this is just for the current level. And then interesting thing is that the bits that are reserved 0 are not reserved 0 here. So there's something interesting going on with this instruction. But so wait, does it translate anything? No, it does fault. So it's using some page table. It's probably mine. Wait, but I just turned them off. So it's... Wait, 0 is mapped? But I don't map 0, do I? No. Why does it not fault on 0, but it does fault on, like, 1? Oh, that's interesting. Oh, is this a hypervisor translation instruction? Is this translating only, like... Oh, it might. It might be... This instruction might be for translating stage 2 only, or something like that. Or maybe it's, like, for the guest, but... Yeah, it might be a that would make sense. That's why they have it, and, like... That's kind of interesting. So if I do that... B0E... And if I HCREL2, if I turn it on, do that, do an ASB. No, not what I want to do. Still works. TLBI, maybe. No, it still works. That's so weird. So anyway, I guess I can't figure out if SPR works or not by using these things. Now it's faulting because, yeah. Why does the search not work? Okay, what's broken now? Mmio.9. What did I break now? Hold on, what did I break now? This should just be translating stage 1. Okay, now it works. Yeah, so I don't know why the SPR thing doesn't work. Yeah, that breaks. Okay, let me go with what Sven said if the PXN UXN bit order is correct. Let's just try that. This PXN is normally the high bit, and UXN, yeah, you'd think it's like that. Let's just try it. Oh. But I didn't turn it on yet. Shell. SPR configure 1, yeah. Ooh, okay, that's better. At least, at least you got feedback. So at least it runs code. That's better than before. Oh wait, instruction abort. Okay. That's interesting. Is that due to TLBs? Because it's just aborting on every... Oh, hold on. Yeah, because of the read... or execute. It worked. Yeah, it worked. It worked. It's just that obviously my call thing isn't going to work anymore because of SPR. Okay, so it probably was that then. The PXN UXN order. Cool. Okay, so then I need to fix that in this mode, which means using the mirror. Okay, let's do it like that. It would be really nice if I could use like a translation instruction to debug this though, but it seems like it doesn't really pay attention to that. At least not with the MMU disabled. Maybe with it enabled it does, but... Okay, so now what I need to do is over here, go to memory, copy these defines over. There's an EL0 region here somewhere. In proxy utils, was it? Was it proxy? No. Did I just define that in what was that? Setup.py. That's not really what I want it to be honest. It's not even used anywhere yet. So, in just fptest. fptest. So, this can go in proxy. I'm not really a define though. I can go outside here. Then in setup, we can get rid of that. FP test. That'll be region RW EO0. And then for the calls in utils, and proxy utils, basically, I'll just do a do it like that. Actually, for these buffers, I always wanted to do that. Says region RxEL1. Yeah, that should work. Chain load. Shell. Yeah, that works. I can turn it on. Doesn't break. Cool. Okay, let's commit that. Search this stuff. Actually, I kind of want to fix those first. Yes. And then this one just needs to be fixed later. And then in proxy client, fp test proxy py proxy utils py setup.py. Yeah, that's a different fix I had to do there. I should put that separately. And that. Call ad hoc code in then fix that stuff. And gonna fix not how code. And then let me do my thing. Yep. That's just the hypervisor stuff. Cool. So now we can add the SPR stuff. Source. And then let's re-enable GXF, and hopefully that doesn't explode either. Yeah, it does not break. Indeed. Cool. So that's enough to enable SPRR, which means the guest can now enable SPRR. We still don't have the guarded stuff enabled in the host, and I'm curious to see what happens when I enable that. So let's see. Get a shell. Config EL1. Turn that on. I keep doing MRS and like that doesn't make any sense. Like, yeah, it goes to silent. Yeah, let me bring that. Anyway, so now we have that enabled, and for the guarded stuff, just enable it. So for example, what happens if I just read an unmapped address? Looks normal. What about an interrupt? Something happened there. Or not. Oh, you see, I'm dumb. What's that? Oh, yeah, you said HCR EL2 cannot be written to from yeah, I remember that. Okay, well, let me just not do that. Temporarily. Oh yeah, but I'm not firing interrupts yet. So let's actually do that. I think it's like, what's the bit I need for that? The mask exception.c. Yes, I think it's like 5 or something to actually turn on the interrupt. And then don't actually mask it. I get set to 7. No, the exceptions are going to the right place. So it's not going to guarded mode or anything with the exceptions, which is nice. I wonder if that's configurable, if there's a bit for like where guarded mode exceptions go or whatever. That could be. That'd be nice too. So we don't have to do any of that. Yeah, that would make sense. Only if you're already in GL. But if the guest is in GL, the host doesn't have to be in GL. So in principle, then I should never have to care about this. The only issue is the HCR EL2 story. Which, speaking of CPU types, let's actually do that properly. HCR bit 27 DG. Well, can I just do like UInst? Oh, are these not defined yet in the proxy? Oh, GL1 call is what it's called. Okay, that broke in interesting ways. So what happened there? Unknown, unknown. Ooh, is CTLR EL1 also locked? That would make sense. But wait. Oh, is it because I already enabled it this way? I have to turn it off and then do an EL1 call. That did not quite do what I wanted. That sounds like GL can't read my instructions. Why? Were those defined, the GXF exceptions? Oh, just here. It just goes. Okay, yeah. Yeah, so that's just going to go on forever, isn't it? Why? Rx should be... RX should be a thing, right? 0101? Now I am setting Rx to that in EL1, perm Rx, which is this mirror here, which is A. So why is instruction aborting? And besides, the MME should be off at this point, right? Oh, that's why. Because the MMU is off and I'm running... yeah. Well, okay, can I just not do this anymore? This many runs with SVR now, so... Just enable it and then restore it. Yeah, we don't need this anymore. Okay, that didn't quite work. Instruction abort. And it's calling something not in the right region. Why? Oh, yeah, because that's a proxy request. And also because that's like not what I'm trying to do here. No, sorry, that's not what I'm trying to do. It's inst. That's what I want to do. Okay, yeah, that works. Yeah, cool. Okay, so this works. So yeah, that. Hate that. Okay, so that works. And now I kind of wonder, like, can I just run mini in GL? And what will happen with the guest in that case? Will the guest always go up to EL or will it go up to GL? Though either way, I don't really care about what mode I'm in, right? Other than like for HDR settings. That also GXF is not hard, like it's not locked on anyway. So I can just enable GXF around guest calls, and it's not like I touch HDR for anything, I think. So I probably just don't care. Well, okay, so let's see what happens with the hypervisor. Go to the hypervisor, and we need to enable SPRR, frame buffering, and then everything's going to be enabled to this. Like we do that last thing. MRS config heal 1. And enable GXF. Config EL1. You should have bits for those eventually, but I guess for now that's fine. And then just jump and see if it works. And in that case, I don't even want to trap SPR. I'm definitely not shattering those. It gets to do that. Let's see what happens. And I'm not even going to trap that. Trap SPR. Nope. Yeah, let's just see what happens. Okay. So. Let's do a cleanup then. Guest. Hold on. There, that's what I would do. Ooh, interesting. Instruction abort on Y. Oh, I didn't chain load. Yeah. I should reinstall that. Obviously, that's not going to work unless... Okay, that did not work. Like, at all. Okay, let's trap everything first. And then trap SPR, track DXF. We don't care about those right now. Wait, am I not mapping the... it's not necessary. Is it because SPR is enabled in the guest too early and then it explodes? No, because I just have the MU on anyway. Let's see what happens. It's probably going to break on some forward or something, but... yeah, well, that breaks, obviously. That needs to be forwarded to EL1 too. EL02, SPR, config EL1, 2. And then the unks. I do have those defined, right? Apple registers. Where did that go? Here. Yeah, it's in there. Okay. Unknown. SPR config EL1Y. No, it's fine. Oh, why is it disabled? How did that happen? It happened because I'm dumb. That's also why I crashed last time. I need to make that. I keep making that mistake. I need to make that. I need to add a guard for that. Okay. Defaulted on getting there. APCTL EL1. APCTL EL1 2 is not there. Okay, so hold on. First, I need to fix that dumb issue I keep having. So this is... Yeah, we don't have a mapping for that, so that's probably why. Oh, this is probably not allowed to be written to with GXF. Right? Yeah. But you know what? We got that. So that's easy enough to fix. It's probably only writes anyway. Yeah, what was the keyboard only argument thing? I forgot. Like, was it stars? It was like some slash slash or star star or something. I remember it got added at some point. It wasn't a thing originally. Ah, yeah. Okay, now it's doing stuff at least. Kina. Yeah, so that was the thing. And that one too, because... Okay. So that's working about as well as it's going to work. So TIDCP, let's turn that back off. And see what happens. Okay, that did not work. What's different? After setting MAIREL1, which is, am I mapping that right? Yeah, I am. Oh, are these also like GL mapped differently? It's trying to read APSTS. It should work. There was a trap for those, though. Yeah, let's do that. Trap, I think Ext or what I called those. CPU Ext. Let's give it that. See what happens. Oh, happy birthday. Okay. Page faults. This is very slow now. It's interesting. Why is it so slow? Did I like turn off the MMU or something? This is a lot slower than it should be. Or maybe it's not slow. Maybe it's just that I'm getting less exceptions now. Oh, it's getting further now, actually. This is more than it's... This is further than it's gone before. I think it's doing stuff. Yeah, it's booting. Extremely slowly, but it's booting. Oh, it's stopped there, kind of. Maybe it's just doing stuff, though. Very slow. I wonder if I have like a paging issue where it runs the guest with like it's not caching the page tables properly or something. That's pretty far though. So it's getting FIQs. Let's not trap. Wait, why? Oh yeah, because I trapped those. Okay, let's not trap FIQs. We don't need that. Okay, so I don't know where it's now. It seems it did something. So let's kill that. And change the vbar thing to not do FIQs. So in that case, it's not in range 16. It's only, well, let's do 0, 3, 4, 7, 8, 11, 12, 15, which I think is everything I care about. And do that again. This is the Mac Mini. Okay. Definitely not getting as many things as before. Some page faults, but that's reasonable. Yeah, it's doing stuff. So those context IDRs are trapped where? TVM, yeah. I should just get rid of TVM. I don't think I need that. That'll just leave APCTL. Yeah, let's kill that. But I'm confused about APCTL. Like, why did that one break? I wonder if there's something that I need to enable to make that work. Need to test that. It's very slow. I'm not sure why it's so slow. It shouldn't be this slow. And now it's the same. Yeah, it's just doing stuff. It's doing things. It's just really slow. Well, this register is used on context switching, which is why you get it all the time. What I don't know is why it didn't work if I didn't trap it. So I wonder if the hypervisor page tables are getting cached properly. Let's leave this in a corner while I try to read the docs. HCR maybe? No, it would be like... maybe TCR. Probably in here somewhere. If these are not set properly, that would explain a lot of things. And these are set here, probably. Origin 0. Should be cacheable. Write back, reallocate, right, allocate, yeah. I don't know if it's making progress right now or not. I'll go to the toilet real quick. That's a bite or something there. Nope, no progress. No visual progress, at least. Why is it that slow, though? Is it doing something I'm not seeing? Hold on. Wait, why do I have 2 run guests there? There's something... Okay, there's definitely stuff going on there. I think I have... yeah, it's 10 milliseconds. Wait, hold on. Oh, it's compiling stuff. Oh, wait, this is like... Huh? That would explain why it's slow. What on earth am I doing there? Yeah, running a compiler every time. I would do it. I have a disassembler somewhere, but I'm But these past things aren't calling to disassembler, so what is? Oh, do I have an instruction? Oh, hold on. That's the issue. Handle impdef. Oh, come on. Why? That's why I'm dumb. This needs to go here. I was formatting every implementation defined exception as yeah, okay, fine. That was dumb. How about we don't disassemble every single trap and then do nothing with the output? I'm sure my SSD loved that too. Okay, that looks a lot better. That's way faster. Hey, it's actually making progress. Cool. It's doing stuff. Ah, and it died, but okay, cool. You got something. What happened? Data abort on 30cc4. Killed my hypervisor. This is, oh, and USB. Ooh, that's interesting. X22. That is not a good address. Why? X22, X22, X7, C04C. Yeah. Okay. It sounds like memory gone wrong or something. Or wait, hold on. 3 is that actually the address of the AVC? 38228. Oh no, it is. Yeah. Hold on. 38228C4OC. No, that is correct. Oh, hold on. Yeah. No, this is macOS is killing my USB probably because it like powered it down or something. Yeah. Yep. That's definitely what's going on. It did some kind of hardware access that powered down my USB device, which means it's time for Mmiotrace. This that is yeah. Excellent. Yeah, see it P manager, exactly. It initialized the power manager, and then that did something to kill my USB. So, this given it's 7 p.m. and it should do some other stuff today, I might leave it here because it sounds like a good stopping point. And if I start doing Mmiotrace now, it's going to be like midnight, and I'm not going to have dinner, and I'm pretty hungry. So let's stop here, and next time, which is probably going to be tomorrow, should be a fun one. Cool. Excellent. So let me commit this. Yes, we got to a pretty nice point. Let's see what junk I have in here. Timer test can go back. And run guest. Yeah, status. It's A, right? Yeah. This is in hv.py. Yeah, we can do that later. And proxy utils, let's put this in here too. Push, actually, let me do the stash. Just make sure I get that. Yeah. Push. All right, there we go. Well, that was good. And tomorrow should be even better. So, thanks for watching and see you tomorrow.